Hello, I am Bruno Bergmans, Vice Chair of the MDS Young Members Group Steering Committee, and I'm here to interview Professor Anand, who is an assistant professor from the Department of Electronics and Communication at Amrita University in Kerala, India. And his paper was recently selected as an MDS Young Member Research Highlight for the month of June 2025, and it was published in Movement Disorders. So it's a paper about using deep learning for the classification of tremor syndromes based on hand-drawn spirals. And I'm wondering, Professor Anand, what made you interested in this research?
Uh, yeah, so as an engineer closely working with clinicians in movement disorder field, I was struck by how much trauma diagnosis still relies on subjective clinical assessment. Even though the technology have been grown so much, especially spiral drawing, as you know, it's a simple widely used technique in neurology clinics and require no special equipment. Yet their interpretation is highly variable. So I saw an opportunity to combine deep learning with the spiral analysis to create a tool that could make tremor diagnosis more objective. uh, at the same time, it should be reproducible and it should be scalable even in resource limited settings. That is the main that is why I came to this field.
And what is the take-home message from your study?
Uh, so our deep learning model showed that even simple pen on paper spiral drawings can be transformed into a powerful diagnosis tool, especially with the help of artificial intelligence like machine learning and artificial deep learning. And our model even outperformed expert human raters in classifying multiple tremor syndromes and demonstrated the potential for artificial intelligence to dictate subtle patterns, sometimes that are often missed during visual inspection or a video protocol. This approach offers a scalable, maybe a low-cost solution for improving trauma diagnosis, and definitely it can be, a complement for clinical evaluation, especially in if you see telemedicine or large-scale screening programs.
And do you have an ideas how you could even improve more on the accuracy of the model? What would be needed for that?
So actually, it is one of the first kind of paper where deep learning, someone applied deep learning to such a large data set. Since it's the first paper, definitely we had some challenges as well. And for training, at least we got approximately 81%. We feel it is a decent one at the first time itself. But again, we did external validation. We got approximately 70%. But I think it can be improved because now I was focusing only on one deep learning model. Where we were focusing on inception ResNet V2 along with Kera sequential model. So nowadays, a lot of other deep learning models are there. Like we can use transformers and so many others. So definitely, I think maybe I will try to work on some other algorithms. And definitely there are some pre-processing steps and data augmentation steps we can add, and hyperparameter tunings, everything. So these techniques may improve the accuracies in future. So yeah, since it's the first one, we believe 81% is a very good percentage, but we will work on it.
Yeah, and it is impressive that it is much
Yeah.
better than what experienced human raters are rating for the spiral. So I think it's very, very nice. And what was the one unexpected thing that you learned from the research and the publishing process? Was there something unexpected that occurred or that you learned?
Uh, so see, one expected insight was how challenging is to externally validate these machine learning models in real world. especially real world clinical settings. Even despite strong internal performance, accuracy drops during external validation, highlighting the importance of cohort diversity, disease heterogeneity, and generalizability. So that is how we faced in clinical side. And on the publishing side, I was surprised that how much effort we need to do while communicating technical sides to a clinical audience. Bridging that gap between engineers and medicine was so much of challenge, but at the same time, it's much rewarding as well.
Yeah, I think it's very nice. And I would like to thank you very much for sharing the highlights of your research as well as some helpful tips and advice. And we're already looking forward very much to the follow-up papers that you are working on.